Hey everyone, I welcome you all to this Git Crash Course by Simplilearn. In this crash course, we will learn Git and GitHub in great detail and become the master of Git and GitHub in less than 2 hours. I am Ishan and I have Anuj with me, and we together will take you through the various topics in Git. We shall take you all the way from how to work with Git and GitHub to resolving conflict issues and tackling problems with various hands-on demos. And we will be covering all of this within 2 hours. So without any further ado, let's get started. Before we begin, make sure you are subscribed to our YouTube channel and don't forget to click on the bell icon so you never miss an update from Simplilearn.
Now, what happens usually that Git is one of the version control system which we primarily used as a development team. So from the development team's perspective, you will be using the Git version control system very frequently for pushing your changes, for storing your source code. So for acting as in like a central repository, which anytime anyone can refer and anyone can do the changes. Now let's talk about a use case here. So let's say that there is a particular multinational company and it's having the offices or development centers across different regions, like different continents, different countries, and it usually happens. So usually the projects are so much diversified that different developers are located at different development centers. Now, in this situation, what are the different problems which a company or such a huge company or multinational company usually faces? So some of the problems is, first one is the collaboration. Many people are present there at different locations, and how exactly we need to collaborate. Now collaboration is of various types. It could be a small communication, it could be like performing the development, it could be like two different people are working on the same feature but they are located into different regions. So these are some of the problems from the collaboration perspective which we get during the particular development cycle. Second, storing versions. Now it's not like in the single version everyone is completing the project or this complete project is getting closed. So usually what happens that for a specific project there might be n number of particular versions. So you can have 5, you can have 10, 20, 30, 40, 50, that kind of versions or the particular different source code versions can be present there. So in that situation, how you're going to store these versions, because ultimately you will not be able to store all the changes into a single version or a single commit. So storing all these different commits at different locations is one of the primary challenge as such here. Next, how to restore the previous versions. Now, when you feel that you want to roll back to a previous version, it's not like you will be taking up some backup into your local system from which you can extract it and then you can perform the rollback. All the versions are present in the version control system, so you will be ultimately using the version control system only to extract these kind of previous versions. So sometimes we are performing some changes, some code modifications, we deployed it into the test environment, but test cases got failed or the validation got failed. In that situation, either you need to fix the source code or you need to roll back. So this commonly happens in production environment also. If the production environment is successful, so you will do the merge or you will do the modification. If the specific production deployment does not work fine, so in that case ultimately you have to do the rollback. And rollback is not something which you will be doing manually, like you will be going to the source code, you will be rollbacking the source code line by line. No, it's not like that, because you are doing so many changes, so many modifications, so it's not possible for you to do that thing manually. So in that situation, what we will do, we will go for a mechanism where we will roll back the commits or the versions itself. So we'll say that if right now we are on to 2.0 and the previous version was 1.0, so in case of rollback, I will definitely go back to 1.0 directly. So I will not do the modification to my source code, but instead I will roll back my source code to the previous version called 1.0, right? Now next one is figuring out what happened. So different ways are there. So if you are doing some modifications to a file and for some reason it got breakdown, so anyone can go to the repository and can really find out that who did the changes here. So if, for instance, it's not like a file system file that if someone changed, so you will not be able to have any kind of track. It's not like that. So anyone doing any kind of modifications to the file or to the changes, that will be definitely picked up when we will be using or when we will be calling off for this mechanism. So this version control system, or the requirement is there that if in case you want to feel out or you want to search out for a specific change which is done by some couple of people or a group of people, that is what we will be having a bigger picture. So it's one of the problem that we will not be able to find out that who really did what kind of modifications and what kind of changes. And then the last one is that in case someone's disk or the file system or local laptop got breakdown, so how we can restore our source code. So these are some of the problems which a multinational organization or particular organization which is having a lot of developers really face during the development process. Right now, what could be the problem of solution for this all problems? Because we mainly talked about collaborations, the restoration to the previous versions, the history of the versions. We also talked about the security, that okay, that if anyone is doing some modifications or changes, so what could be the safe mechanism to prevent that. And the last one was that how exactly we can talk about the backup of our source code. So all these problems are basically solved by a version control system. So version control system help us to collaborate or put up all the source code into a single location. Version control system can act as a backup because all the local repositories are available at local developer machines, but the remote repository is always available at remote server. It also helps us to detect the changes or to track that who exactly did what changes. And it also talked about the rollback. There are a lot of mechanisms where we can go back to the previous commits, we can do the rollbacks, we can revert our source code. So a lot of features are really present by the version control system which can support or which can resolve all these prime problems. Now these problems are not subject to organizations, because definitely whatever organization and a particular team you pick up, these are the generic problems which every organization faces. And that is the reason why we have a generic solution called version control system, which is available as such over here. Right. So version control system is a mechanism using which it's a kind of a repository, you can talk about. It's kind of a location where a kind of source code, the centralized source code, is available there. So all the different developers actually do the modifications and they store their source code into this version control system. So this version control system provides a flexibility to the developers to check out the latest source code, to do the modifications, to update their source code. And as per this diagram, as you can see that there are 3 workstations, which means that 3 developers are there, and all of them are doing either the update or commit task to a single repository called particular remote repository. So in this case, we are not talking about Git specifically, we are not talking about subversion. It's a generic architecture which is followed by a particular complete version control system. So in version control system, you will have multiple working copies or different local repositories, and then you have a centralized remote repository where all the source code or all the developers will collaborate the source code into a single location, which means that if any particular system or any kind of developer's machine is breakdown, they always have a remote copy present on the remote server from which they can check out the source code. So this is what a typical version control system looks like, where all of our source code is collaborated centrally into a single location. Right. So it's kind of a system that records all the changes made to a file or a set of files, and it also or we call it as a kind of a version or revision, or we also call it as a commit ID. So different version control system using different kind of naming conventions for these versions. The system makes sure that all these team members basically work on these repositories. They do the modifications locally into their local working copies, and from there they basically push their changes to the remote repository to a single location. And that's how the different developers really collaborate their source code with each other with the help of a version control system. Now Git is one of the version control system which we have, and it's also known as a distributed version control system there. Now Git is something which is really popular at right now over here. Before the Git, Subversion was quite popular and a lot of organizations were actually using it. But now Git is a kind of a version control system which helps us to track the changes just like any other version control system into a particular working copy or into our particular laptop. Now it's having a certain benefits which is exactly not available in any of the other version control system. So it's used to coordinate the work among the developers. So different developers are actually collaborating with each other with the help of this version control system. They are able to track the progress. The senior developers or the leads or the managers can always find out that what are the different changes a developer is doing, how the different commits are happening there. So it's a wonderful feature of a version control system that you get a complete tracking, you get a complete history. So any person can go ahead with the version control system and they can really find out that what exactly it's happening into this one. So all those features are definitely provided by Git also. It is used to have act as a kind of collaboration tool so that multiple developers can really push their source code to this remote repository. And then again, it also provides us the tracking mechanism to track the overall progress of the development. So the main work of Git is to manage the projects, and a couple of repositories are managed here. And in these repositories, you manage your work, you manage your source code, and the developers perform various kind of activities like checkout, check-in, push, pull, different activities they do to interact with the source code. Right, so Git can be useful for both programming professionals like the developers and all, and non-programming particular professionals also. Now as a DevOps engineer, if you are not doing the programming, still you can use the Git repositories for having your files, for having your source codes, your scripts. You can store Ansible scripts, you can store Puppet script, you can store Python shell scripts, all that things you can do it. For you, it is a kind of a source code. For developers, they can store Java source code, .NET source code, Android projects. So that's a kind of a source code for those particular programming language or for those teams. Now, that is the reason why Git is really helpful over here, because it provides the comfort or it provides the help to both the programming professionals and the non-programming or non-technical professionals also, right? So it also helps in coordinating the work among the team because of the tracking feature, history feature, and the collaboration here. So different developers can actually use these repositories so that they can push their source code to this single location. And then in fact, different developers can, take updates. They can even find out that what other developers are doing. So they can do the sync up, and even if someone is not giving you the, the particular details, still you will be able to get it from the repository. So that's a kind of a good collaboration mechanism or tool which can really help to increase or improve the communication between the different developers. So what exactly is a Git repository? Now a Git repository is a place where we keep all the files related to our project stored there. Now there are two types of Git repositories. One is local repository and one is the remote repository. Now when we work with Git version control system, so what happens that we have a central remote repository which is available there on the Git server. Now this is something not present in local system, it's on remote server. So when you do a clone activity, when you bring that repository into your local system, now what happens that in Git version control system, it does not create only a working copy, but in fact a local repository is created. Now this local repository is having the link up, or it's having the connectivity with the remote repository. So whatever the changes you will do, if you push your changes to the remote repository, that is something which will be possible with the help of this version control system. So here it's not like every time you will be interacting with the remote repository. Whenever you feel that you want to push some changes to the remote repository, at that moment of time there are some couple of operations like push and pull activity which you will be using to interact from the local repository to the remote repository. So local repository is the one which you will be bringing on when you clone the remote repository. Now remote repository is the repository which is having the main important source code. So using the local repository, you will be interacting with the remote repository, and that's how the various kind of operations, you can do the modifications, whatever the commits you have performed, you will push it, you will pull it. So all those activities you will be able to do with the help of local and remote repository. So these two type of repositories are available, which we can further use to make our changes and perform our particular source code changes here. Right, now let's talk about some of the git commands, because ultimately when we work with the git version control system, we have to do a various kind of operations like pushing the commits, performing the merging. So all those commands, let's talk about that. Now the very first one, the basic commands over here is that git config. So git config is the mechanism using which we can configure the username and email ID. Now why we require this? When you will be doing some git commits or you will be doing the modification, so as a standard feature of version control system, it preserves the author details, like whatever commit it wants to do. Whenever he wants to create a new version, it has to embed some of the author details. Now this author details involve an email ID and a particular username. Now this email ID and username, if you don't configure, in that case some dummy system related email ID and username will be picked up. So in that situation, we will not be able to understand that whether the particular check-in is done by a developer or it's being done by a particular machine. So for better understanding, to get a better comfort, that's the reason why we use the git config over here to configure the username and email address over here. Then we have git init command. Now this git init command is used to create an empty bare repository. So this command, when you run, you will be able to create a bare empty repository, and after that you can further on do the modifications, you can add some commits, you can add some files, and all that stuff you can do over there pretty much. Then when you add some files, now what happens that when you do you want to go for a git commit activity, before that the files should be present in the staging area. Now staging area is a location where you will be preparing or you will be storing the files temporarily before even performing any kind of commit. So git add and git commit command is something which is executed into a sequence. First of all, you will run the git add command to bring all the changes or all the change file into a staging area, and when you done the git commit command, so all the files will be committed. Now git commit command will not take up how many files you want to commit, because whatever the files you will put up into the staging area, git commit command will read all those files and it will perform single commit for them. So if you feel that you want to only check in 2 files out of 20 files, please go for the git add command and first add only these 2 files into the staging area. If you add all the 20 files into the staging area, then all the 20 files will be modified and a new commit will be created there. Then we have git diff command. Now git diff command is used to see the changes made to the files, to see the difference. You can use git diff command with the branches also to see the difference between the 2 branches. So git commit command is something which makes sure that all the changes are saved permanently into the local repository. So git add and git commit command are executed into a sequence, so that first of all you can add the files to the staging area, and then git commit command will pick up those files from the staging area and preserve permanently as a commit into the local repository. Then we have git reset command. Git reset command used in various types. One time you can use it as in kind of just to reset the changes in the files, and in a certain way you can also use it to delete the commits from the git repository. Git status command displays you the state of working and the staging area. So git status command also tells you certain particular features, like what are the different files which is in the modification state, how many files are there present in the modified state. So all those information is something which we are getting from the git status. Git merge is a very good feature because whenever we work with the different branches, so Git merge is a mechanism to move the changes from one branches to another. So if you are required to do the modification to the develop branch and you want to move those changes to the master branch, in that situation we have to merge develop branch into the master branch. So it's a kind of a mechanism to move the changes from one branch to another. Then we have git push. Now till git merge command, all the commands you can run to the local repository, which means that you don't require any kind of remote repository. You can simply work on the local system, and without any network connectivity with the remote repository, you will be able to perform those changes. But git push is a mechanism to push or move the changes from the local repository to the remote repository. So whatever the commits you have done, every time it will not interact with the remote repository. Only when you run the git push and pull command, that is where you will be performing the interaction or communication between the local repository and the remote repository. Push is to push the changes from local to remote repository, and pull is something which is pulling up the updates from the remote repository to your local repository. Right, now let's talk about some of the basic Git operations here. Now so far we have seen that what are the different basic Git commands are there, which we use time to time to perform the various operations and various tasks within the version control system of Git here. Now let's talk about some of the basic Git operations as such here. Now the very first one operation over here is the initialize of a Git repository. Now this is something which we perform to create a kind of a new repository or a new project. Then we have add operation to add some files. Then add operation is used to add some changes or modified files to the staging area. Git commit is something which is used to create a new version of the group of files. Then pull is to bring down the changes from the remote repository to the local repository. Then push is there to push the changes from the local repository to the remote repository. So these are some of the basic operations which we perform so that we can move the changes from one state to another. Now the first one is git init command. Now it's used to create a new and empty repository, where a repository over here. Now once the git init command is executed, what will happen? You will run the git init command in a folder. For example, I have created a folder called git repo, and in that I have initialized or executed the git init command. Now the moment you did the execution of git init command, so what will happen? A .git directory will be created in that system. So this .git directory represents that you are working right now onto a Git repository. You can also further run the git status command and find out that okay, this is the repository preserved over here. But if you don't have the .git directory, it means that it's a plain folder and it is not a kind of a Git repository. Now remember, .git folder is only the folder which is created there. There will be no files which will be created as such in this one. So git init is only creating a bare empty repository onto the system. Right, now once the repository is initialized, so you can further on go ahead and add some files, some folders, or whatever stuff you want to perform in that repository. Right, so in this diagram you can see that when you run the git init command, you will be able to see the .git directory created over here, and you will also see that that's the only folder structure which is created as such over here. So on Windows machine, you will be able to see it pretty easily because of the file name, but usually in the Linux platforms, .git is specifically designed or is known as a hidden folder. So all the files and folder with dot in front will be considered as hidden there. So in that case, you can run ls-lart to get on and to see the content over there. Then we have add operation. Now once you fire the modification is done, so once all the changes are performed there, so you will be adding the in order to perform the commits, first of all you have to add the files to the staging area. So staging area is in a particular temporary location where the git commit command will look upon, and all the files which is present in the staging area will be picked up, and all of them will be preserved or will be converted to a git commit. So before running the git commit command, git add command is required for the files to be added so that we will be able to move them to the commit here. Now in this case, you can see that git status is the one which we are running to check on which status we are right now, and we have modified like a file called alpha.txt. So git add dot is what we are trying to run over here, and then you can see that from the red color, earlier it was an untracked file, but now it's became in tracked files, and it says new file. And then further we did the git commit. So at that moment of time, what will happen, that this file will be completely checked out into the repository. And further after this one commit, if you run git status command, there will be no file present there. So git add and git commit command are executed into a sequence so that they will be able to have a proper commits there. Now the commit is in situation where you will be changing your history of your repository. It makes sure that the changes which you are doing is permanently preserved into the git repository. So git commit command requires a particular flag called -m. Now -m is something which is there for providing custom message for what reason you are doing the git commit. Now if you don't provide this message, your git commit will fail, but you need to provide a message to specify that what is the reason behind performing this commit activity. So that is what you are trying to provide over here with the -m over here, and preserving and providing the details that yes, this is the reason why you are performing a commit activity into your local repository. So you can see here that we are giving a particular commit message called beta gamma, but in real world you will be providing some commits like fixed debug bug 120, or fix this feature, or fixed this functionality, so that we will be able to see from the commit message that what is the reason behind this commit here. So we don't have to unnecessarily go inside the commit and find out the details. All the details we should be able to get it from the commit message. So that's the reason why it's very important that we provide a valid commit message, right? Then we have the next operation over here is the pull. Now pull is something which is used to fetch the latest updates from the remote repository and then merge those changes back to your local repository. So just kind of operation in which we are taking up the update from the remote repository. The purpose of taking update from the remote repository is that because different developers are collaborating or uploading their source code to this remote repository. So in that situation, if we want to take some updates from the remote repository, that is the reason why we will be using the git pull command to get those changes and merge it into your local repository. Then you can have some example, like we can run the command called git pull origin master. Now it will copies all the files from the remote repository to your local repository. So it will do a sync up of master branch of remote repository into the local repository master branch. You can have the it's in combination of two commands. One is the git fetch. So first of all, it downloads all the content, and then git merge, it combines all the sequence of commits into the specific branch. So it's internally, when you run git pull command, it fetches the specific contents. Now when git fetch command runs, it does not really changes any kind of modifications into your local repository. Ultimately, when the git merge happens, that is where the code changes into your local repository. But if you alone run git fetch command, it will not perform any kind of changes to your local repository, right? Here you can see that we are pulling up the details. So here we are pulling up the details of our first repo, and when that is done, so we will be able to see some details out of that. Right now, then we have git push command, which is used to push the changes from your local repository to the remote repository. You will be doing a various kind of commits into your local repository. So at some moment of time, you need to sync up or move those changes to remote repository. That is where we will be running the git push command. So git push command is required. It needs a network connectivity, and before git push command, if you want to do some changes, you can do that. And once you want to share or you want to bring those changes to the remote repository, that is where you will be able to run the git push activity as such. So this is a kind of a mechanism using which you will be able to push some changes from the local repository to the remote repository. So here you can see that we are pushing the changes from the master branch of our local repository to a remote repository. And in this case, as you can see, that it here says here as a new branch because the remote repository was empty and there is no master branch present over there. So that is the reason why it says new branch over here.
Let's have a look at the demo where we will push files and a folder to the Git repository. So now for the demo, we will begin with opening our Git bash. In the Git bash, we will start with configuring our name and email ID. For a name, I'll type git config global user.name. The name I'm using is Simplilearn GitHub. Now for the email ID, what I'll do is I'll again use the same statement with user.email, and in the case of email ID, we do not need these double quotes. So the email ID I'm using is siddham.bharat@simplilearn.net. Now let's check if the configurations were set correctly or not. For this, we'll check git config list. In the list, we can check here that we have our name, user.name and user.email. So we have as it is, we had set it. So moving on, now let's check the address of our remote directory. By default, we are always placed into our home directory. Now we will create a folder in this directory from where we will create all our Git repositories. I will create a folder with the name Git _demo. So now we will again check the location. The folder is empty as of now. We can navigate to this folder and check. This is our folder. We can check this is empty. So now let's create a first repository. Our first repository we will create with the name of first repo. Now let's again go back to that folder and check. So we can check we have this first repo now. This folder is empty. Let me create a repository for this folder. How do we do that? We do that with the help of git init command. This means a repository has been initialized. Now when we go back to this folder, we can find a hidden file created. This folder is created with the name of .git. I can see that folder because I've enabled the settings of viewing hidden files. If we get into the folder, we see a bunch of directories and configurations. Make sure you don't make changes to any of the directory. Now we can see something called as a master appears on the screen. Whenever a Git repository is created for the first time, it creates a branch. The name of the branch by default is the master, and that is why we see this master on the screen. Now let's create a few files for a folder. We will use the touch command for it. Let's create the file with the name alpha. When we type this notepad command, we can see a notepad appears on the screen. I will type beta gamma inside this notepad, save it and close it. Now let's check the status of this file. Now it shows that no file is yet committed. We can see the untracked file in red color. Now what we need to do is add these files. We can add these files with their specific name, or we can simply write git add space dot. Now when we again check the status, now when we run the git status command, we can see there are no commits yet, and the files that were earlier in red color have now become green. It also shows a remove command in case we want to unstage or undo the changes. Now we can go on and commit this file. For commit, we will type git commit space -m, and in double quotes we'll type beta gamma. Now we can see one file changed and one insertion made. So when we move further, let's have a look at the logs of all the files. For logs, we'll type git log. Here we can see the commit ID of the file that we had created. Now let's make one more commit. We will do the same process again. We will again type the touch command. This time we'll keep the file name as beta
Then we'll again type the notepad command. This time in the notepad, we'll type alpha and gamma. Again, we'll save it and close it. Let's make some changes in the previous notepad file we had. So for that, we'll again type notepad alpha.txt. This time, let's add beta, gamma, and delta. We again saved it and closed that file. Let's now check the status of all the files. We'll type git status command. We can see it shows that alpha.txt has been modified and beta.txt is still untracked. We again need to add these files. So for adding, we'll again type git add space dot. Now let's commit these files. For commit, we will enter the text. The text was alpha space gamma. We can see 2 files changed, 2 insertions made, and 1 deletion. Now, when we have all the changes and the files with us, we may want to share these files with someone else and work in a collaborative way. So for that, we will push the repository to a Git server. Here, I have my Git account logged in. So I'll go here, make a new repository. As the new repository, I'll keep the name as first repo. Then the description is optional, so we will just create the repository. Now when our repository is created, we will copy this git remote add origin command, go back to our git bash, and simply paste it here. So now for git push, we first need to execute the git remote command. Now let's push our files to the Git repository. For that, we will use git push space -u origin master. We can see there are things that have been pushed. Let's go back to our GitHub and check. Let's open our repository and see if the files that we wanted have been pushed. Here we can see all our 2 files have been pushed. Let's check the content for it. Alpha.txt, it has got beta, gamma, and delta as we have saved. And beta.txt, we have alpha and gamma as we have saved. Now, let's also see how we can push a folder. We will make a folder. Let's make a folder with the name Git Demo. In the Git Demo folder, we will put our Git presentation and let's put the Git PDF also. Now we will copy this folder and take it to our directory. In our directory, we will paste the folder here. Then we will go back to our git bash, add this, and now let's commit this folder. For commit, we will type git commit space -m and let's write add folder. As we can see, 2 files changed, 0 insertions made, and 0 deletions. So that means it's time for us to push this file. Now, we will again push with the same command. Now, we can see there are things that have been pushed. Let's go back to our GitHub and check. So let's refresh it. Here we can see our folder with Git Demo has come. Let's open this folder and now let's try to download this PDF. We can see this is opening here, and now when we are trying to download, we can see the entire PDF of our presentation here. Now, when we know about the basics of Git Pull, let's go on to see the working of Git Pull with the help of a demo. In the demo, first we will pull content from our remote repository to our system. Then we will make changes in that folder and push it back to our remote repository. So now we will begin with opening Git bash and creating a directory into it. The directory that I will create is, I'll create it with the name Git _demo. After I've created the directory, I'll check its location. I'll go to the directory. We can see there's nothing inside Git Demo as of now. Then I'll create the directory with the name changes. Then let's go and navigate this directory as well. We can see there's a folder with the name changes. As of now, this folder is also empty. Now let me create a repository for this folder. We can create a repository with the help of git init command. As we can see, now an empty Git repository has been initialized to our changes folder. We can go back and check. Here in the changes folder, we can see a .git folder is there. This folder is hidden. I can see this folder since I've enabled my settings to view the hidden files. If we get into the folder, we see a bunch of directories and configurations. Make sure you don't make any changes to any of the directory. Now let's go back to our Git bash. Now let's pull the directory that we created in the last demo of Git push. For that, we will go to GitHub. In the GitHub, we will go to a directory. Here we'll go to clone or download and copy this URL and paste that URL here. When we paste the URL, we can see the contents being pulled back. Here, when the contents have been pulled back, let's go and check the contents. When we go back to that folder, in the changes folder, we can see Git Demo, Alpha and Beta. If we go on to check the content, in the Beta, we have Beta, Alpha, Gamma. In Alpha, we have Alpha, Beta, Gamma, Delta. While in the Git Demo folder, we have the Git PPT and the Git PDF. So now, we will make changes in these two notepads. And after that, we will push that same notepads back into the same directory. Now let's open the notepad first. For opening the notepad, I will put the location of those notepads. The name of our notepad was Alpha. So in Alpha, I will delete Alpha from here. I'll save it and close it. Then I'll open the next notepad, that is with the name Beta. Here I'll delete Beta from here, save it and close it. So now let's check the status. In the status, we can see alpha.txt and beta.txt are modified. So we will use the git add command. Now to commit the changes, we will use git commit -m changes made. We can see 2 files change, 2 insertions made and 2 deletions. Now let's check the status of the file again. Now when we check the status, we can see there's nothing to commit at all and the working tree is clean. Now when the changes are made, we will push all these files back to our repository. So for that, we will go back to GitHub. Here in the GitHub, we will copy this URL, come back here, then we'll type git remote add origin and paste that URL. In the next step, we will write git remote -v. We can see the fetch and the push command in order. In the last step, when we have to push everything back, we will write git push -u origin master. Now we can see the contents have been pushed back to GitHub. So let's go back to our GitHub and check the contents. When we go back to GitHub, let's refresh it and see the contents of the file change. We can see the changes made, the commit name that we had given. So when we open alpha.txt, we can see there's no alpha. We have deleted it. It's beta, gamma, delta. And when we open beta.txt, we can see beta has been deleted. Only alpha and gamma is there.
So these were some of the Git operations which talk about that how we can do some basic information and basic stuff over there. But now next thing which we have over here is the advanced Git operations. Now in this one, some couple of operations involved as in Git branch. Then we have the Git merge, and then we have the Git rebase here. Now the first one is the branch. Now a branch is in kind of a way of doing a parallel and independent development over here. Now at some moment of time, you feel that the developers needs to work on the source code or the changes independent of each other. So in this situation, you will be giving either a feature branch or a development branch to different developers. They will be doing their respective changes to these branches, and then further on you can do the sync up and you can merge the changes to a single branch according to the requirement. So the commits are done isolated from each other. So if you're doing some commits in develop branch, it will not put any kind of impact on the master branch. So git branch command is used to create a branch, to list a branch, to delete a branch, or to particular rename a specific branch also. Then we have merge. When we are talking about branching, then merging is also an important task. So the merge command is used to move the changes or one or multiple changes from one branch to another. So it is a mechanism to perform a sync up of the commits from one branch to another. So git merge command is used to combine two branches, and it's some kind of a mechanism in which we find out a single base, a common base, and then on top of that we move the changes or we combine the two branches here. Now git rebase is also performed for the same approach, but the process of rebasing refers to moving or combining a sequence of a commit into a new base commit. So git rebase is something which is doing a little bit restructuring of the commits, and normally git merge command is involved in which it can preserve the specific base commit, and on top of that it can add up your commits and it can do the modifications. But when we talk about rebase is something which is combining the commits, but it also preserves, or it may end up in having a new base commit as such over here. So git rebase is somehow doing some modifications and restructuring the overall baseline of the commits, right? So git rebase command is used to integrate the changes from one branch to another here. Now let's talk about that what exactly is a merge conflict. Now merge conflict is something which gets originated the moment we do some kind of merging activity. Now merging is a process in which we move some source code from one branch to another. Now all the developers cannot work on the same piece of branch there. So what really happens that in that situation, all the developers mainly work on some couple of branches and then they all collaborate to some other branch, or different developers try to push their changes from the local repository to remote repository. So in all these situations, the source code gets moved from one location to another. Now what happens in, as per this diagram, we have a remote repository over here. Now all we are trying to do is that we are trying to push some source code over here from a particular developer here. Now he is doing the pull and push activity, and this another developer is there who is also doing the pull activity here. So merge conflicts basically happens then, for example, this particular developer A is trying to do some push, right? So that push is almost done here, and when the particular developer V is trying to push the particular results or try to push its own content to the remote repository, he got a merge conflict, which means that his particular developer B merge activity is cancelled, is deferred here. Now it could be a possibility because of the changes on the difference on the two piece of source code there. So let's talk about that. Now in order to prevent such kind of conflicts, developers usually provided with the isolated branches so that they can work on their branches, and once the development is done they can do a single merge and they can sync their changes into a single branch. So the git merge command combines separate branches and resolves any conflicting edits over there. So once the developers are done with the specific changes, with the modifications to the source code, later on they can combine those things, they can work on these components, and they can resolve all these conflicting modifications, right? So a merge conflict is an event that takes place when Git is unable to resolve the differences in the source code between the two commits automatically. Normally the Git is having the capability to understand that okay, these are the two different piece of source code which is getting pushed to a remote repository, but in any case it does not happens automatically. There is any kind of conflict which arises over there and Git is not able to take any kind of decisions. So in that situation we will be able to get a merge conflict. Now it could be a possibility that one merge can happen successfully, then the next merge will be cancelled and will be deferred due to this merge conflicts. So Git can automatically merge the changes only if the commits are on different lines or the branches here. So if at any moment of time you are diverting from the process, you are having some different lines of source code, so that is where the merge conflicts comes into the picture. Now, what are the different kind of merge conflicts which we normally face? The main types of merge conflict is, first of all, there are 2 points where we can say that a merge can happen or can come into a conflicted state. The very first one is the started the merge process. Now, if at any moment of time there are changes in the working area or working directory, and we are moving, or these changes are getting moved to the particular working area of the stage area of the current project. So during the merge activity itself, the particular merge will fail because there are some changes or there are some kind of modifications which is right now present over here in the working area. So in this case, conflicts happen due to pending changes. Now, for instance, you have done some modification to the changes. Now you were planning to do the commit, but before that you felt that I want to do some kind of merge. Now, since there are some pending changes which is available there into your working area, so what will happen that your merge will definitely fail there itself. So before even starting, before even initializing the merge, as in particular pre-check, your merge activity will fail there itself. So in that situation, you have to either remove those pending changes or you have to resolve those pending changes before even going for the merge activity. Second, during the merge process, definitely if you are getting some conflict, so the merge conflicts gets originated. So the failure during the merge process indicates that there is a conflict between your local branch and the branch being merged, right? So you're trying to move the changes from one branch to another, so it means that there are some particular conflicts which is coming up in the particular branch in which you are trying to do the merge. So in this case, Git resolves as much as possible. So if there is any kind of difference in the source code, in the commits and the different line of source code there, so Git automatically try to resolve it as much as possible. But at any moment of time, it's not able to do, it's not able to manage. In that case, a particular human interruption is required so that we can merge or we can resolve these particular conflicts manually there. So these are the two types of situations in which a particular merge can enter a particular conflicted area. Now, how to resolve these merge conflicts? Now, what happens that in order to resolve these merge conflicts, the simple way to do this is that we open the file which is in conflicted status. Now, once that is done, you do the required changes. Whatever source code you feel you want to proceed, you will select that source code, you will use that source code, and once the edition or editing of the file is done, so what you can do is that you can run the pretty much straightforward command called git add to add that file to the staging area. And then what you can do is that you can do the git commit activity so that the particular merge conflicts can be resolved and you will be able to see a merge here. Now this is something which is known as one of the best approach for resolving the merge conflicts, because even if it comes up, if Git is not able to handle it automatically and it requires for you to manage it manually here, so definitely in that situation we have to open the source, we have to select that which portion of source code we want to keep, do the modifications manually, and then follow the traditional approach to perform a custom commit. So git add and git commit command you will be doing there in that situation to have a particular final merge executed all together. So this is the steps which we can follow to perform a custom to resolve a particular custom merge conflicts over here. Right now, the various git commands which we can use to resolve the conflicts here. Now, git log -f merge is a command which helps us to list down all the commits that are causing the particular conflict here. If at any moment of time your merge is failed down and you want to see that what are the different commits which is causing the issue here, probably you might be ignoring some commits which is not that much important, or you can manually override the content so that those conflicts data can also be added, and whatever the changes you are trying to add, that also should be modified. Second command, git diff command, you can always use the to check the difference between the particular files between the repository. Git checkout is something which you can use to particularly check out a file, so that if you want to check out the latest content of a specific file or a folder, so in that case you can make use of this git checkout command here. So git checkout command will definitely help you to understand that how we can go for, or how we can do the checkout of this particular repository or a particular file here, right? So then we have a command called git reset hyphen mixed. So git reset hyphen mixed is a command to undo the changes of to the working directory, and whatever the particular changes you have, so that will be undo there, and it will be able to do the undo changes to the working area and the staging area here. Now then we have git merge hyphen abort, which will be used in order to exit the merge process and return back to the state before the merging begin. If you're not able to resolve the merge conflicts manually also, so in that situation we will be aborting the merge situation or a git merge over here. And the last one is git reset. So git reset command is used at a time to of merge conflicts to reset the conflicted file, so that what we can happen that we can go back to the previous situation before even starting, or the state before the merge activity was started there. So git reset will eventually help me to reset all the files which is in conflicted area, and latest files will be checked out and will be replaced. So these are some couple of commands which we can actually use in order to resolve the merge conflicts into a Git repository. Now that was something which we were trying to understand, that what exactly the Git merge was there, and how the Git merge originated, and how the Git particular merge conflicts gets created, and how we can resolve it. Now let's go for a proper demo on this one, so that we can understand it properly, that how exactly Git merge conflicts really work and how we can resolve it. Now this is the Git bash which we have installed to run some Git commands. Now in this one, first of all, I'm going to create two repositories. So I'm going to run the command called git init a, that will initialize a repository, git init b, that will initialize a b repository here. So two repository I have got, a and b. Now in basis a, what I'm going to do is that I'm going to add the remote. So git remote add origin. So I'm just trying to add the origin over here. So the origin over here in this one is the Maven build. So this is a repository which I have got into my GitHub account. The moment you do this, what next you can do over here is that you can run the particular next git pull command to fetch the latest updates here, right? So next, move to the particular next command here. Now when you do this, what will happen that all the changes which is present in the remote repository or central repository will be available here also, right? So you will be able to see some couple of files all together here. Now the same activity you have to do in the particular B directory also, or in the particular B repository also. So you have to add the URL, the remote URL here, and in this case also we are trying to fetch the particular values here. Now what will happen that we will be doing some modification in the particular A repository, and then we will be pushing that change to the remote repository, and then through the B, when we try to push the changes, so in that situation we'll try to see that what really happens. Do we really get the merge conflicts? Because both of them, although is trying to do the changes to the central repository, but these two repository represents two different local repositories, probably in two different developers machines over here. So that's what we are trying to replicate here. So I'm going back to the A directory here, so that I would be able to do some changes altogether. So I'm just opening readme.md file here. So pretty much I'm just trying to add some particular changes over here to this particular file. So this is what we are trying to do here. Now let me add some particular additional and a particular new line over here in the file, and then save the content. Now once this is done, I will be able to see that yes, there is a particular change which is done all together here. So you will be running git add command and then git commit command to save the commits all together. So we are giving a particular commit here so that we will be able to identify that this is something which we have committed from a repo A. Now once this is done, I will be doing the push activity so that I can push these changes to the particular remote or the central repository here. So exactly what we did over here so far, we have a particular downloaded remote repository in a repository A, and then we are doing some changes, some modifications, and once those modifications are done, we are pretty much changing or putting up that new commit all together to the GitHub repository. So this is what we are trying to do so far over here in this one. So this git push activity will take the particular access, right? So when I do the particular push activity here, so if the credentials are saved, then that's fine. Otherwise it will ask for the particular username and password all together here. So that will be asked by the particular activity here. So it will ask for the password. So all you have to do is that you have to just share that password, and your git push activity should be passed on or should be done there. And as you can see, the changes really got moved to the GitHub repository. Now sometimes the credentials get expired, so you may get some particular message saying that you have to put some password there. A particular interactive window will be open there, and you have to prompt or you have to provide that password, and according to that it will proceed further, right? So this will eventually help you to move the changes into the GitHub repository altogether. So all of your changes will be pushed to the GitHub central repository, right? After some time, it really pushes my commits to the remote repository. It will take some time depending on the network connectivity and the kind of changes you are trying to upload. So now since my particular repository is done, so what I can do is that I can further go back to the particular directory here. Now what we can do is that we can go back to the B repository over here, and in this case also I'm just trying to do some modifications. So for instance that I'm just trying to do the changes here to the readme file, again a kind of a changes in this one. Now in this case I'm trying to delete this line, the last line I'm trying to delete here, or a couple of modifications I want to do over here, like added data from repo, and then furthermost I want to have, let me do some arrangement, like let me have this data added all together over here, or I can add it, yes. So data is added and this data is removed. So the idea is that we can do different kind of reshuffling of the data up and down so that we can understand that how it really works. So I have shuffled the data, I have removed a couple of lines, and let's see that how it works, right? So I have even added some couple of lines over here. In this new line I have added one line, I have removed from the last, and this particular line I have shifted 5-6 line up over here. Now let me save this file and then run the git add command. After this we are going to run the particular commit here saying commit from repo B. Once commit is done, same activity, pushing it to the remote repository. Now let's see what really happens. Now when we are trying to push this particular change to the remote repository, after the change was pushed from repo A, it will throw an error saying that the particular, due to the conflicts, the updates are simply rejected here, right? So in this case what really happens, that because we are having a different stream of source code in a remote repository, and from local repository you are trying to push some different line of source code. So what next you need to do is that first of all you need to do the activity called git pull -- reverse origin master. So you're going to pull the changes from the remote repository so that you should be able to get some particular content all together in this particular repo B over here. Now the moment you run this, let's wait for this activity. Now once that is done, you will be able to see that you are seeing a message saying that conflicts are there. So first of all you have to resolve these conflicts and then it will be proceed further. You have some couple of options, like you have to resolve the conflicts manually, and because Git is not able to handle it, Otherwise, once the git conflicts is resolved, you can run git rebase hyphen continue. If you want to skip this commit, so you can say git rebase hyphen skip. And if you want to abort the particular this rebase here, so in that case you can run git rebase hyphen abort. Now since we want to manage or we want to resolve this conflict manually over here, so what we need to do is that we need to open the merge tool on this one. So once you open the merge tool, from there you will be able to resolve those changes manually and then continue with the rebase. So let's go with the git merge tool here. So we are going to use the command called git merge tool. Now when you run this, so what will happen that it will process, it will open the normal vi command line over here, and all the files will be processed all together. Now this is the modifications, right, which is which is done over here. So we are just trying to see that which particular file or what resultant file we want to configure here, right? Now in this case, since you are able to see that this is the final file which is present, and here exactly the merge conflicts comes up, because you can see that 3 different files are given to you in this side. So you have some files in which you added new 2 lines, and here you added this line there, this artifact will be there. Now here you also added this particular new line instead of having this line default here. So what exactly happens when you scroll down, you will be able to see that where exactly is the particular issue or what are the different modifications you done there. So in this one, if you scroll up and down, you will be able to see that what exactly it happens. So the main area of conflict is first of all this area. So this should not be there as per git, as per the normal file, but yes, if it is there, so we have to see whether we want to continue or we want to proceed with this particular specific file or not. So yes, so I will say that okay, let's remove this line. Let's not let's copy this line. Let's delete this line here and add the line over here in this one, and place this line also from here. So this is what I'm just trying to make use of here. Now here I just want to have the particular line pasted. Okay, deleted. So this line I will okay, so I have added this line in the final. I'm just trying to resolve this conflicts manually. I'm just editing this file here, trying to remove this one, this one, this one, and this one. So this is how my particular final file looks like, and I am good to go to this one. Now you have resolved the conflicts manually by doing the modification to the file. Now just press :WQ, save the file over here, and then close the other files also. Right, so this is how I have done the modifications, and I should be able to continue further now. So what I'm going to do is like I'm going to run command git rebase hyphen continue. Now once that is done, so the particular commit which or the modifications which you have got over here, so that is something which is totally done, and yes, the rebase is finalized over here. Now again, this is the manual modifications which you have done, so you should be good to go to push to remote repository. So again, in this case, what you're going to do is you're going to run like git push. Before that, if you want to check the particular git log, so you can check the particular git log over here. So the last commit which we were try to doing like commit from repo B is also available over here, right? So A and B both changes are present now, so we should be able to push the changes to remote repository. So it will take some time to do the push. And as you can see, It's trying to put some content, so we'll still wait for the final confirmation so that we can assure that yes, all the conflicts is resolved. And yes, that's correct, all the particular conflicts are resolved, and we should be able to see both commit A and commit B into the repository. So let's go back to the GitHub portal and see that if we really got those particular commits in that. So when we access our particular repository on GitHub, so we should be able to see that we have got an activity that the commit is checked in there. So if you go to the commits part, you should be able to see that you have got these commits gone process altogether. If you click on any one of the commit, you will be further able to see also that what different changes you actually moved. So this is the way that how you can resolve the conflicts, and you can take care of the changes from two different developers or for two different push activity. So that's it for this particular demo. I hope you liked it. Thanks everyone. So we are done with the demo, and we have understood that how we can resolve the merge conflicts with the help of some couple of commands. Now in this, we really have got an understanding that how the different ways of merge conflicts really gets originated, and how we can help or we can make use of some git commands to resolve those things.
Before diving deep into the subject, let's first have a look at a use case. The use case we will consider today is of the world's largest sporting goods retail brand, Decathlon. Decathlon has 1,600 stores spread in 52 countries with around 100,000 employees. The IT team of GitHub consists of 1,000 members that helps Decathlon to bring its shopper's journey to their devices. So here, we will first see the problems that they faced, and then we shall see how did they sort out that problem. In the beginning, Decathlon worked on the data center with the help of a VPN. And using a VPN was a huge challenge in terms of workflow visibility and avoiding redundancies. So the first problem is how to maintain workflow visibility and avoid redundancies. Then, since there are so many stores located at so many different places, hiring of developers seemed to be a difficult task, as a physical workplace was always needed. So the second problem is, how would they hire developers? Now, let's see how did Decathlon solve these two problems one after the other. In the first case, the entire Decathlon shifted from any other remote repository to GitHub. GitHub turned out to be an amazing open source community, as the code became more visible across the organization and now anybody could contribute to it. Then, let's talk about the second case for hiring the developers. As we know, GitHub is an open source community, so it helped in collaboration with any developer all over the world. The potential developers could now contribute to benefit the global community. Now the question arises, what made this contribution possible? So the major contribution role was played by the version control system. This was just a single case amongst many others. There are many organizations that have benefited from GitHub.
Now let's talk about GitHub. Now what exactly is a GitHub there? Now there are some common scenarios where we think that okay, Git is different and GitHub is different. No, it's not like that. Ultimately, GitHub is nothing but an organization which internally uses the Git repository only. So they are using the Git solution only, but it's kind of a web-based graphical interface which is given to you just to have a better interaction with the Git repositories. So it's kind of a Git repository hosting service which is available there. So for example, you have the various hosting machines like GoDaddy is there, different other vendors are there, but ultimately they provide the same virtual machines like Linux, Windows and all that. Similarly here also they are all using the Git only, but they are providing it in as a kind of a good interface. They're providing you certain features, and these features are somewhere you can have the security, you can have the user base, you can have the permissions. So all those features you get with the help of the GitHub here. So it's a kind of a web interface which is given to you just to interact with the Git repository, to create them, to manage them, to delete them, all those activities. So it helps every team member to integrate with each other and at any moment of time. Now this is something which you can access anywhere. If you are using the public version of GitHub, you can use the repository anywhere with any network. But if you are using a private network or a private repository, in that situation, definitely in your office or into your network, you will be able to access. But it primarily depends on the way that how you are doing the modification and how exactly you have done the changes so far and so over here, right? So it's one of the good collaboration tool which is present, which primarily talks about that how we can do the modifications and how we can move the changes from, we can have the collaboration between different developers and they can really do the changes and those modifications. Right now, what are the different features which we have of GitHub? So let's talk about that. Now, some of the features are present over here in this way that represents that what are the mechanism and understanding about the specific GitHub here. So let's talk about these features. Now, the very first feature of this one is the easy project management. Now, it's a very good platform where you can, have different kind of access levels. Project managers and, developers can coordinate, they can track and they can update their work. You can manage the repositories, you can manage the access, you can perform the changes, you can perform the rollback. A lot of things can really happen there, and everything is recorded, nothing. So even the account activity is also recorded. So if someone is creating the repository, is deleting the repository, all that information is there. So it's kind of a easy project management where at a single location all the repositories are there. So it's quite easy for you to manage and to work on these repositories and to talk about them. Next, we have effective team management. Now, it helps all the team members to stay on the same page and stay organized. So it's a kind of a modernized tool which is available there to so that different people can, work on the same platform. They don't have to learn different platforms here. As such, on the same platform, they will be able to collaborate and they will be able to, work with each other. Then improved code writing. So there are some features like pull request, which gives you functionality before even doing the merge activity. You will be able to do some review. So it definitely helps a kind of a check which is there, that before even doing some kind of merging, you should be able to review it. You should be able to see that what exactly you are trying to do, what kind of commits you are performing, and that can really helps to do some improvements to your source code, to your overall source code. So that's an additional check which is provided by the pull request feature of GitHub. It's not a typical merge only. It's something someone will review, someone approve it, then only the merge activity will happen. Now, GitHub uses different tools to identify and analyze the issues there. So there are some tools or features which is available there in GitHub where you can also further on increase or analyze the source code and analyze the issues with the source code there. So development teams can work together to to secure the software supply chain. These particular say repositories are quite secured, and that is the reason why not everyone have the access or default access to the source code. So this is quite restricted, and due to this feature, it's easy to maintain the high quality of your source code, right? And then we have the easy code hosting here. So all the codes and documentations are present in one location. There are millions of repositories which is available there on GitHub, and each repository is comprises of its own source code and its own different people having the access, right? And then it increased safety with packages. Those packages can be published privately. You can have both public and private access. The packages can be used or reused by downloading it from GitHub, and other variety of applications is there. So if you're working on open source, in that situation it will be publicly available. If you're working as in privately for an secure organization, in that case it will be available privately there.
Let's see the differences between Git and GitHub. Git is a software that can be installed directly onto our systems, whereas GitHub, as we saw in the demo, is hosted on the cloud. Then, Git can be used offline. We don't typically need an internet connection unless we need to access the GitHub, whereas GitHub can only be operated when we have an internet connection. Next difference is Git is something independent and can be used without GitHub, whereas GitHub has nothing to do unless we make repositories in Git, which means it cannot be used without Git. Then, Git is a version control system that helps in source code management, whereas GitHub provides centralized hosting of the code on the cloud. Next difference is Git does not work according to a graphical user interface, while GitHub is a simple graphical interface. Next difference is Git is a command line, so it operates on several commands like commit, merge, push, pull, etc. Whereas GitHub is a web-based service, so it has nothing to do with command line. Then Git is released under the GNU General Public License, which is an open source license. It ensures that the software is free for all its users. Whereas in the case of GitHub, there are two tiers, a free tier and a paid tier. In the end, let's have a look at the competitors of the two. As a competition, Git has Mercurial, Supervision, IBM, Rational Team Concert, and ClearCase. While for GitHub, the competition is Bitbucket. So we will begin with opening our Git bash. Then in the Git bash, the first thing that we will do is to configure the username and the email ID. So for that, I will type git config global user.name Simplilearn at _ GitHub. Then I'll configure the email ID. In this I'll write global user.email. For this I don't need double quotes. The email ID that we are using is siddham.bharat@simplilearn.net. Now we can see in the configuration list whether these things are there or not. So for that we will check. We can see our username and user email are present here. So moving on to the next step, we will check the address of the remote directory. For that, we will type pwd. We can see the location of the remote directory is C users rahul.arun. Now, here we can see the location of the remote directory. Moving forth, we will create a folder in this directory from where we will create all our Git repositories. So for creating the folder, I will type make directory. Let's create it with the name git_hub. Now let's navigate to this folder. We can see the location of the folder. So we will go here. Here we can check our folder is there, GitHub. When we go inside it, we can see the folder is empty. So let's create a repository for this folder as well. So we will create this repository with the name comparison. Now let's navigate to this folder. Now we can see a folder with the name comparison is here. When we go inside it, we can see the folder is empty. This is the folder that we will be using as a base for all our repositories. Now let's initialize a repository for this folder. For initializing, we will use git init command. Here we can see an empty Git repository has been initialized to our folder. Now let's go back to that folder and check. Now when I enable the hidden files, I can see a .git folder appears on the screen. This .git folder is created. If we get into the folder, we can see a bunch of files are there. We can see directories and configurations. Make sure you don't make any changes to any of the directory. Now we can see something called the master appears on the screen. Whenever a Git repository is created for the first time, it creates a branch. The name of the branch by default is the master. And that is why we see this master on the screen. Now let's create a few files for a folder. We will use the touch command for this. Let's say touch alpha.txt, notepad alpha.txt. We can see a notepad appears on the screen. In this, we shall write alpha, beta, gamma. We will save it and close it. Now let's check the status of these files. Now it shows that no file is yet committed and there are untracked files that could be seen in red. Here we can see alpha.txt is untracked. Now we can either specify the name of the file or simply write git add dot. Now to add this file, we can give a particular name or we can simply write git add space dot. Then let's check the status once again. We can see there are no commits yet, and the files that were earlier red have now become green. It also shows a remove command in case we want to unstage or undo the changes. Now we can go on and commit this file. For commit, we will type git commit -m, and let's say we type beta gamma. We can see one file changed and one insertion made. Moving forward, let's check the log of all our files. We will type git log. It shows the commit ID. There's the author name, the email ID used, the date, and the commit message is also there on the screen. Let's make one more commit. We will do the same process again. We will type touch beta.txt notepad beta.txt. Another notepad with the name beta opens on the screen. In this again we shall type alpha, beta, gamma, and let's write delta also this time. We will save it and close it. Let's now check the status of this file. We can see there's one untracked file, that is beta.txt. So we will first add this file, then we shall commit it. Let's type alpha gamma this time. We can see one file changed and one insertion made. Now let's check the log again. We can see the commit IDs for two files now. So now when we have all the changes and the files with us, we may want to share these files with someone else. And this is when GitHub comes into picture. So when we want to push these files from our local repository to our remote repository or from our system to our GitHub, we will need to use the git push command. So now I will go to my GitHub. I have my GitHub account logged in. I will create the repository with the name comparison. The description is optional, so leaving it for now, we will simply create the repository. Now we will copy this git remote add origin URL, go back to our git bash, paste it here and press enter. Now we will type git remote -v. Now we will type git push -u origin master. We can see the GitHub login opens on the screen. We will put our username and password here. So I will put. Now, as we can see, all the things that we wanted have been pushed onto our remote server. So let's go back to GitHub and check. When we come back to our Git server, when we come back to our GitHub, we shall see alpha.txt and beta.txt are present on the server. Let's open this. We can see in alpha, we have alpha, beta, gamma. Then let's open beta. Here we can see we have alpha, beta, gamma, and delta. These are the notepads that we just created, and they have been pushed from our system to our GitHub.
Let's have a look at the competitors of GitHub. There are several competitors in the market. Here we have just put the most common ones. First is Atlassian Bitbucket. Then comes Fugbugs, followed by Surround SCM and GitLab. Then we have Buddy, and finally followed by Beanstalk. Who doesn't know Goldman Sachs today? Goldman Sachs is a multinational investment bank that provides a vast number of services in the financial sector. This 151 years old organization is headquartered in New York and works with over 38,000 employees. The organization provides a vast number of services like investment management, securities, asset management, prime brokerage, and security underwriting. But no matter how huge the organization is, it surely faces some challenges. The biggest challenge in front of them was to increase software quality and developer efficiency. They needed to find a way towards concurrent development activities and to achieve faster development cycles. The possible solution to this challenge was to have a tool that helps the team to remove toolchain complexity and will help developers to manage everything in one user interface. This would help in centralization and version control. Goldman Sachs chose GitLab to help the engineering teams to remove this complexity and accelerate the adoption of DevOps. The DevOps application helped developers to perform all the tasks in one user interface and also simplified their work with one central instance for all repositories. GitLab is a web-based Git repository that allows users to work on free repositories. One can choose whether to keep their repository to be private or public. GitLab is a complete DevOps platform that enables the team to build a better software along with working with each other. Before we move further, it's important to know what is Git. Git is the most commonly used version control system that helps in tracking changes made to the files. Hence, we may have a record of all the changes that have been made in a file, and we can also revert back to a specific version. Coming back to GitLab, GitLab reduces the time and cost of development cycles. And lastly, one can opt for a paid version of GitLab if they want to access more functionalities. Now, let's have a look at the demo where we will start with GitLab and make our first project into it. So now, we will begin with opening gitlab.com. In the gitlab.com, I will log into my account. After I log into my account, I will create a new project. Let's keep the name of the project to be tutorial. In the project description, which is option, I will put I am creating a demo tutorial. Let's keep it to be private and create the project. After I've created the project, we will begin with opening our Git bash. In the Git bash, first we will configure our username and email ID. For configuring the username, I'll type git config -- global user.name. Let's say the name is tutorial. Then for the email ID, I'll type user.email. It is ishan.gaba@simplilearn.net. After we have configured the email ID and the username, we will create our first repository. For creating the repository, I will type make directory tutorial, create directory tutorial. We can go and navigate to it. Let's go to C users ishan.gaba, and here we can see the directory is there, tutorial. For now, the folder is empty. So we will come back here and initialize a repository to our empty folder. For initializing, we will type git init. As we can see, an empty Git repository has been initialized. Let's go back to that folder. Here we can see .git folder appears on the screen. It is a hidden folder, but we can see it because I have enabled my settings of viewing the hidden folders. When we go inside the folders, we can see a collection of files and folders. Make sure you don't make any changes to these files. And along with that, we can also see something called the master appears on the screen. Now anything that happens in the repository can be tracked. Now let's make a file or a notepad that we can push onto a remote repository, that is the GitLab. So for that, we will create touch, let's say input.txt, notepad input.txt. We can see a notepad appears on the screen. We will write input gives output. We will save this and close it. After that, let's check the status of this file. For that, we will type git status. We can see there are no commits yet, and we can see there's an untracked file input.txt. To add this file, we will type git add dot. And to commit this file, we will type git commit m input. The message we are giving is input. We can see one file changed and one insertion made. Now Let's check the status of the file again. When we check the status, we can see there's nothing more to commit and the working tree is clean. Now let's go back to our GitLab once and check if there's anything. On the GitLab, we will go to our projects. In our project, this is the one, tutorial. So when we go inside, we can see there's nothing at all. So we will come back here and push the file. There was nothing there since we haven't pushed anything yet. So we will go to the GitLab, come here and take the git remote add origin command for pushing. We will copy this command, come back to our git bash and paste it here. Then we will type git remote -v followed by the push command, git push u origin master. As we can see, the pushing process is taking place. Now let's go back to our GitLab and check if there's anything that has changed. We will come back to our git bash, go to our projects, go inside tutorial, and here we can see input.txt appears. When we open this input.txt, we can see the input. Input gives output. This is how we can push our files, folders or notepads from our local repository to our remote repository. And so with this, we have reached to the end of this Git and GitHub crash course. We hope that you guys found it informative and helpful. Do like and share it. Thanks for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.